In this video, we're going to talk about 8.3 Objective 2, where we solve problems of direct variation using the constant of variation. So what they're talking about here is any direct variation problem can also be written in the form of y equals kx, where y divided by x equals k. K is a constant of proportionality here. So for instance, the cost here is going to be a function of the weight. So we have 159 over 781 grams is going to be that many dollars or cents per gram. They want us to round to the nearest 10,000th of a dollar. So tens, hundreds, thousands, 10,000s, so 0.0020 per gram, like that. And that would be our, if we knew the number of grams, then we could multiply by that constant and we could figure out the cost. So let's compare unit costs here and see if there is this, which one is better in example 2. So 139 divided by 792, and we get 0.001755. 051 as our K1. K2 over here is going to be 0.59 divided by 422 is going to be 0.00139810. And surprisingly, the smaller can is the better buy. Normally, we think you get a better price if you buy a bigger can. But in this case, you get a better unit price if you buy the small can. The number of kilograms of water in a human body varies directly with the mass of the body. So a 93 kilogram person contains 62 kilograms of water. So 62 equals 93K. 62 divided by 93 is 2/3. 2/3 equals K. And then we want to say what is the amount of water in a 75 kilogram person. Well, that's going to be 3 goes into there 25 times. 2 times 25 is 50. There should be 50 kilograms of water in a 75 kilogram person if 2/3 of their body mass or body weight is water. A blueprint has a scale of 1/2 inch equals 1 foot. On the blueprint, a wall is drawn 10.5 inches long. What is the actual measure of the wall? So we can just set this up. 1/2 inch is to 1 foot, as 10.5 inches is to, we can set it up the last way that we did before, but we can also solve it this way and say if 1/2 inch is equal to a foot, that 1 inch is equal to 2 feet, and then we have 21 over 2 inches times 2 feet per inch, like that conversion factor, and the 2's will cancel, and we end up with 21 feet. So that's our y equals kx conversion factor situation there. Let's try this again, that we have 5 1/4 inches times 1/4 inch is 1 foot. So this is 21 over 4 times 4 feet. 4's will cancel and give me 21 feet. A building that is 76 feet long would be shown as what length in a blueprint, where the scale is 1/2 inch is 1 foot. So 76 feet times 1 foot is 1/2 an inch. Feet will cancel. 76 over 2 inches is 38 inches. Building that is 84 feet long would be shown as a length of what on the blueprint if it's 1/4 of an inch equals a foot. So 84 feet times 1 foot is 1/4 of an inch. 84 divided by 4 is 21. I like 21 as an answer today. Scale on the map is approximately 5/6 of an inch to 20 miles. The distance from city A to B measures 3.5 inches on the map. 20 miles, 5/6 inch. Then how far apart are the two cities? So this is going to be 3.5 times 20 divided by 5/6 is 84 miles. A map that the distance between two mountains is 5.5 inches. The actual distance between the mountains is 128 miles. Russ is camped, so let's figure out this conversion factor. 10, 11 halves. Well, let's just leave that. Russ is camped at a location on the map 3/4 of an inch from base of the mountain. How many miles from the base of the mountain is he? So let's figure this out. 5.5 divided by 128. Then I need that divided by 0.75. Let's do it this way. 11 halves x equals, what's 3/4 times 128? 96. So 96 times 2 divided by 11 is, round to the nearest whole number is needed, so 17 miles. X is 17.45 repeating, and that's about 17 miles. Machinist is to make the metal plate represented in the figure to the right. What is the overall length or base of the actual plate? So one side of the square is 1.75 inches, and so he needs a length or base of the plate that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like 12 squares. So 12 times 1.75 should be 21 inches that he needs, and he'll need to cut stuff out of that, but he needs a piece of metal that's at least 21 inches long. They didn't ask us this, but he'll need a piece of metal that's at least 1, 2, 3, 4, 5 times 1.75. So he'll need a piece that is at least 21 inches by 8.75 inches. So this is length and this is width, just so he can be able to cut this out and have enough metal to make that shape. Okay, that's it for this video. I'll come back next time and talk about 8.3 Objective 3, which will be a different type of variation that won't be direct variation. I believe it'll be inverse variation. So we'll see you for the next video.